Hello, everyone, and thank you again for joining us for today's webinar titled HashiCorp Nomad, a simple way to orchestrate your containers, which will be presented today by Dan Kirkwood, Senior Solutions Engineer at HashiCorp. I'm Ilcha Markowski. I'm a product specialist with HashiCorp. So today, Dan is going to show us how HashiCorp Nomad provides a streamlined approach to scheduling both modern and traditional application runtimes and how it compares to other well-known orchestration platforms. Before we get started, just want to go over a few housekeeping items. First of all, I'd like to note that this session is being recorded and the recording will be made available within the next day or two. I will send you an email with the link. Secondly, please submit any questions you have through the demo via that QA tab, and we'll get to them at the end. So with that in mind, let's go ahead and get started. Over to you, Dan.
Awesome. Thanks very much, Ilch. And good morning or good afternoon to everyone on the call. Thanks for giving us your time today. My name is Dan, and I'm really excited to be talking with you about Nomad. Before we get there specifically, I want to talk a little bit about HashiCorp. And really, the way I like to think about our company is about our mission. Our mission at HashiCorp is to help businesses unlock what we call the cloud operating model. This is a framework around the management of infrastructure and applications with the aim of increasing agility without sacrificing things like stability or security. Hopefully you've heard of or maybe even used one of our tools in the past. They're listed there on the right-hand side. Some of these tools are closer to the infrastructure side of things. Others are concerned with cybersecurity or networking, but a really large part of what we do is very close to the application. And that's where we're going to be spending time today. With each of our tools, what we aim to do is create a standardized control plane for common automation tasks, which might stretch across your single or more likely multi-cloud environment. So, whether you're all in on a single public cloud, whether you're only just starting your cloud journey, or maybe you're using select offerings from different IaaS, PaaS, and SaaS providers. Our tools offer a consistent experience for infrastructure provisioning through Terraform, secrets management with Vault, network automation with Consul, and of course, application orchestration, which really brings us to today's topic, which is Nomad. If I think about two of the most often repeated themes when I talk to my customers about application modernization projects, they are in the title of this slide. Almost everyone is doing one or both of these things today: moving to cloud, moving to containers. On the flip side of this, I don't have any customers who have been able to do both of these things completely. Right? I don't think any business, maybe a few, but not many businesses at meaningful scale use, purely microservices on a single cloud provider. So most likely, kind of like the diagram on the right-hand side here, you're going to end up somewhere in the middle. You're going to have particular workloads that remain on VMs. You're going to have a data center or two, which are going to take some time to exit. Then you're going to have new applications and a subset of your existing apps, which are going to be refactored and containerized. And one thing to keep in mind is that there are some substantial challenges with containerizing an application and then running that container in production. If we think about the app dev side of things, just understanding how you might decompose your monolith and all the dependencies between that code, that's a huge challenge on its own, and it's probably, a topic for another time. Today, we're going to be focusing on how you might operationalize that container once the development work is done. And I think it's no secret that running containers in production at scale is complex. I think it's also no secret if we think about the environment, the possible options that you have for container orchestration. For example, the different flavors of Kubernetes, it's no secret that those are complex as well. There's a few different reasons for this, but really I think it's because for platforms and operations teams, there are suddenly a whole group of new considerations per application And then also you've got microservices that are operating at a scale which is an order of magnitude larger than most of these teams are used to working with. And I think that the risk here is that these complexities can lead to project failure. I've seen, many businesses embark on app modernization projects or container orchestration projects that have gone nowhere after 12 months because no one could predict the complexities of decomposing the app and the complexities of running the platform. And, this is really the opposite of the cloud operating model that I mentioned earlier. This is supposed to be about agility and innovation, right? So this is really the challenge that we set out to tackle with Nomad. The goal of Nomad is to bring the benefits of orchestration to containerized and non-containerized applications. It aims for a great, consistent experience for developers and for operators across your clouds of choice and on-prem. And this kind of balance of simplicity and flexibility is what people who run Nomad really love. You could start in a single region of a single cloud today. Tomorrow, you could add another region or a cloud and federate those two with a few simple commands. Your developers can have a local environment where their orchestration experience is exactly the same as they would have in production. And these are all things that are actually really hard to do with other orchestrators. So again, the guiding principle here is to orchestrate any application. And this is not limited to the Docker ecosystem. This is not limited to a particular OS or only to containerized applications. And what this does is it allows companies to do incremental application modernization. Teams can avoid, the big bang approach where you have a huge overhaul and you need to tackle every problem at the same time. This means that teams can containerize at their own pace. And it means we really minimize that risk that I spoke about earlier around project failure for application modernization. So we have two really simple starter use cases for Nomad, which are on the screen. On the left-hand side, container orchestration, on the right-hand side, non-containerized orchestration. And really, we're going to spend our time on the left-hand side today. And, this is not something that you just need to take my word on. There are a number of small and large teams that are using Nomad to do container orchestration today. And, this is just an example of our public reference customers who are running Nomad. So let's look a little bit closer at container orchestration with Nomad. And I think a good way into this is, we spoke to our customers about why they might use Nomad for container orchestration when they've got lots of tools out there to choose from. And the three reasons, the top reasons that they gave are the 3 points on this slide. First up is time to value. Nomad is a single binary. It's about 30 megabytes, and it can be really easily deployed into your environment. This means that you can then really quickly start on your proof of concept cycles, and then you can also then really quickly move into production. On top of this, thinking of time to value, anyone who's already used another HashiCorp tool like Terraform or Vault or Consul gets a few extra benefits here. One is that you've got this common configuration language of HCL. If you know how to write Terraform code, you also know how to write Nomad configuration or a Nomad job spec. Secondly, these tools have really deep integrations, which means if you want to do something like injecting secrets at runtime, it's a lot easier to achieve. Our customers also like how easy it is to then get other teams to adopt Nomad. Nomad provides a really simple onboarding experience, and you get this really minimal time that it takes for a developer who is new to the tool through to the time that they're able to deploy their first application is really short, and our customers love that. The last point here is critical for anyone that doesn't plan to hire additional people to build and maintain their orchestration platform. We have some customers that are literally a one-man band, a single person maintaining a web service or an API that gets millions of hits per day. We have other lean teams of about 4 or 5 people that can run this platform and service hundreds and hundreds of developers. What I thought I'd do today, I am a solutions engineer. I can't resist getting hands-on. And I thought I would actually show you some of this in action and kind of demonstrate, this idea of how might you get started with Nomad. And you can follow along, right? If you're technically minded, I would encourage you to do this as well. What I've done on my local machine is I've downloaded the Nomad binary from the HashiCorp website. So just search Nomad download, and I've put it into my path. For me to get started, all I need to do is run Nomad agent dev. So I'm going to start a development environment with Nomad. This is going to spin up everything that I need to then be able to deploy applications into this environment. If I scroll back up to the top of this output, we can see that this has started a web service on port 4646. Let's take a look. And this is Nomad, right? I am up and running with the latest version of Nomad. I don't have any jobs in here. We're going to run one in a second. But first, let's take a look at what does Nomad know about my environment. Here I have a worker node, which is actually just my laptop. We can see at a top level that I get a view into the resource utilization of this worker node. I'm in a webinar sharing my screen, so this doesn't look too pretty right now. But here's one of the first things that any orchestrator is going to use to decide where should my application be scheduled. The other top level information that we've got is that Nomad knows what is the capabilities of my machine to be able to schedule applications. Yes, I will be able to run containerized apps here because I've got Docker. I could also schedule Java jars on this machine because I've got the Java runtime. I could also use this machine as a hypervisor. I could run VMs on here with QEMU. Lastly, I've got raw exec. So I could schedule any binary that exists on this machine, any script. I could orchestrate that with Nomad as well. So my resource utilization, my drivers, what am I compatible with? This is top level information that Nomad is going to use to schedule jobs. I then have a huge amount of other attributes that I can use to help Nomad make an intelligent decision. We can see here, I'm running on a Mac. So I've got a Darwin operating system. I might have particular jobs that I want to schedule onto a fleet of Macintosh boxes. I've got other jobs that are only going to run on Windows boxes. So I can use the OS as a decision point there as well. I might have particular Java versions that I want to target for my legacy applications. And I want to have worker nodes that can service those applications as well. I might want to know something like the amount of free space on a disk and help that inform my deployment decisions as well. Okay. This is just showing you, from the start, what kind of visibility do I get into my orchestration environment, which again, for me, is just my local laptop. What we're going to do is we're going to schedule a job. Here I have a directory with an example job for Redis. I'm going to run this job. With Nomad job run redis.nomad. We're going to take a look at what that file looks like in a second. But here we can see the deployment underway. If we now look into the GUI, we now have an active job. Nomad is spinning up 3 instances of this Redis job. Now we're talking about containerized applications today. So Redis is running in a container. There's nothing particularly special about how it's running, but I want to show you a bit of the process here. Nomad has selected an appropriate worker node, which is the only available worker node, and has deployed 3 instances of my app. If we look now from my laptop's perspective, I now have 3 instances of that Redis application running. And we'll look at some of the particulars of that deployment as we go today. But, and again, for anyone who's following along, I hope it's obvious to you how easy it is to get started with, number 1, getting the environment up and running, and number 2, the ability to submit a job. And again, this experience of me interacting with Nomad is going to be exactly the same here on my local development environment versus a single cluster I have in a single region versus a worldwide deployment I have with many federated regions. Okay, so let's take a look at some of the specifics of how have I actually submitted this job into Nomad. And I'm going to keep running through the slides here, but I'm going to bring my code alongside as well. So we have a bit of a comparison point here. Let me shorten this. Cool. Here we have a Nomad job spec. This is that way that we define as code, a declarative way to define what do I want my application deployment to look like. And I hope that as you look at this, similar to a lot of people's experience with Terraform, you can look at this at a glance and pretty easily understand what I'm trying to do with this deployment. To go into detail around some of the, the logical constructs for this job, we have the top level idea of the job itself. A job is a collection of one or more groups. A group is a collection of one or more tasks. How do I define what a job is? I could have my entire environment defined as a single job. The challenge there is all of those applications in my environment then have the same lifecycle. I deploy them all at once. I update them all at once. So probably more realistically, you're going to work out which applications do I just deploy once and they just run over the weekend. Which applications do I deploy when I bring my environment up, and I hope they are extremely long-lived and I only update them once a year. Which applications need to be updated multiple times per day? Those are going to become different job files for Nomad. I then have this idea of a group. A group is co-located tasks that should exist on the same host. Within my group, I might have a task for my Redis, my cache, which might be my main application container. I might also have a container that does log shipping. I might also have a container for my service mesh or for secrets injection. That's going to make up my group. Think of that as an equivalent of a pod. I then finally have one-to-many tasks. And here is where I actually map the idea of the driver, which we saw earlier. So I'm going to using Docker, to the unit of the application, which in this case is a container image. Coming back to this idea of drivers. Okay, so I'm using Docker here. In the context of containerized applications, I might also use containerd. I might also use something like Podman. If we're thinking about Windows environments, there is a specific driver for deploying IIS web applications. Other plugins that we've got, if you're in the world of Firecracker VMs, there is a driver for that as well. Then on top of all those specific drivers, there's of course that idea of an exec. What is an arbitrary application that I want to run or schedule using Nomad? I've also got different ways of defining how I want the scheduler to treat my application. What type of scheduling do I want? Our Redis container here is scheduled as a service. I would say this is, a typical starting point for containerized applications. This is, a long-lived app, something like a web application or a database, or in our case, a cache. I can also use Nomad for batch scheduling. Okay, if I've got short-lived workloads that have a defined start and finish, something like reporting, we've got large banks who do financial analysis using Nomad to schedule millions of containers at a time to run their analytics software. I can also have the idea of system scheduling. This is a kind of task that is also long-lived, but I want one of these things to exist on each Nomad worker node that I've got. We've then got this idea of lifecycle. So if I've got my file here, which is the declarative view of what I want my deployment to look like, I can submit this file in the first instance to define the job. If I ever want to update that job, I just update the file. So for an example, we're going to change the count here. I'm going to double the amount of Redis containers that we've got. And I'm going to run do a dry run against this deployment. So we can do a Nomad job plan. And Nomad can give us a view as to, you know, how realistic is it for this change to happen? And what does that change look like? So it can detect that the only thing that's changed is the count, which is good. It's then done a scheduler dry run to make sure, can I actually allocate these jobs? Do I have enough resource? Do I have enough machines that have the Docker driver available? Have I exhausted something else like, you know, high-level ports that might be needed to schedule this job? All of that can be run within this concept of a job plan. And of course, you know, I'm running this kind of manually here from the CLI today. More realistically, in a production context, you're going to have your CI/CD tooling that is running these steps and automating the process of interacting with Nomad. So I can see that, yeah, this plan all looks pretty good. We're just going to run, not the plan again, but the run itself. Okay, and Nomad's going to take that idea of the plan and implement it as a change against my environment. What we're going to see is an additional number of instances of my Reddit app, my Redis app being deployed. If we then look at other types of updates, right? So I've just scaled out there. There's nothing particularly special about that. But what if I changed my code? How does Nomad handle that change? We give an inbuilt way for you to be able to do different types of updates, rolling updates, blue, green, or canary. And for example, here, we've got a canary update that I've defined. This means that any change to the application itself will run a canary before we do anything that touches the actual production deployment. I'm going to show you that really quickly. We're going to move this Redis image to 6.9. I'm going to skip the plan just for brevity. I'm going to execute this. Now, I know that 6.9 actually doesn't exist. Okay, this is a tag that doesn't exist. What we can see here is that Nomad has scheduled my 2 canaries, my 6 kind of production Redis containers exist untouched. And what we're going to see here is Nomad is going to try and schedule these jobs. Now, the image pool is going to fail, right? Because this image doesn't exist. And eventually this task will fail. That will then give me a mechanism to know, okay, with my canary deployment, do I want to actually roll this out? Do I want to promote my canary into production? Or do I want to revert? The nice thing about this is it's all built into the tool and can be then augmented. So there we've seen the fail. So what I'm going to do is fail the deployment as a whole. As I failed that deployment, you can see here that we're actually rolling back to a previously known good version of this job. I mentioned augmenting there. We might want to augment this with a Consul health check, for example. You might want to augment this with metrics that are coming back from your APM. But there are lots of ways that you could integrate Nomad with observability or visibility tools to, again, drive the automation of this process and you know, drive the updating of your code for those apps that need to update often. So again, here we're back to a healthy state. We've just back on our regular 6 Redis containers. And, you know, they're the same ones that were untouched, even though we tried to do an unsuccessful update to the code there. How are we doing for time? We're getting near the end, so I'm going to roll through some of these last features quite quickly. Of course, you've got the idea of namespaces. You know, as a system like Nomad goes beyond a single team, you're going to want to think about how do I make this a multi-tenanted platform? And of course, it's possible with Nomad namespaces. Again, thinking about app modernization and how you're going to be doing scheduling for both, you know, modern containerized apps, but also other types of applications. Of course, we can do stateful apps as well, and we just plug into the CSI ecosystem to achieve that. Likewise, on the networking side, if you've got a network overlay of choice that you want to keep using, Nomad can work really nicely with that as well. So with all that, and before I finish up, I want to leave you with some final thoughts. Number one, your application modernization project will have complexities. Nomad can help you minimize the risk of that project. And the other thing I want to point out here is, that idea of a consistent experience from a dev environment through to a small prod environment through to a multi-cloud federated cluster is really important. And it's something that's going to keep your dev teams really happy. And finally, we're not ignoring operations here. There is a simplicity to Nomad that is going to save your business time and eventually money in the long run. That's it for me for content, and I'll throw back to Ilch to close us out.
Great preso. Thanks for that, Dan. Excellent presentation and demo. I'm just looking to see, we've had some questions come through in the Q&A. They've been answered. There's one left here quickly. I think we've got time for one more. We've selected Consul for our service mesh. How could we leverage Nomad to work with Consul? From Anonymous.
Oh, yeah, good question. So I guess the nice thing about Consul, and coming back to that idea of a consistent control plane across all of your environments is, if you were to go down the Nomad path, you're not going to move everything there overnight. You're probably going to have VMs, maybe you've got Kubernetes or, another container orchestration system like ECS sitting somewhere else. Consul can work in the same way across all of those environments. So I could actually bring together service registry or service mesh for my VM environment, my Nomad environment, my ECS environment. And then I've got the benefit of, consistent network policy between those environments, consistent health checking, consistent traffic routing. There's a lot of really nice stuff you can do in regular operations. Once you're in a migration situation, Consul can then help with traffic steering as well. So your app that exists today on a VM and then moves into Nomad scheduling land, Consul can help you load balance traffic between different instances of that app as well. So there's a lot of really cool things you can do in that space. Yeah, good.
Fantastic.
Question.
Got a couple more questions. They've just spread it up. So we're just going to do our best to answer them before the half an hour's out. How can we leverage Nomad for a hybrid OpenShift on-prem and EKS deployment?
Yeah, good question. So you've kind of mentioned there some other orchestrators, right? The question would be, are you getting the efficiency out of those orchestrators that you would like? There's nothing that Nomad can do on top of them. We're not doing a manager of managers here. We want Nomad to be managing applications in the same way that EKS or OpenShift might. So I would think about what is the developer experience when we're submitting jobs to those platforms? What is the operator experience of maintaining those platforms? You've already got two. Is there a bit of disparity between the two? I would think as Nomad as a future direction to help you standardize across maybe your on-prem where you've got OpenShift today and your AWS environment where you've got EKS. You could have just Nomad instead.
Yeah, fantastic. And just flying on from that, is it possible to run Nomad tasks from another server using Terraform?
Possible to run Nomad tasks from another server using Terraform. It's really interesting, actually, the intersection between Terraform and Nomad. And I see, teams that manage application deployments via their Terraform code, absolutely. And whether you're interacting directly with the Nomad API, there is a provider for Terraform, or you're using Terraform to do, template files. You might take in variables, what's your environment, what's your release cycle, which region are you targeting? Those all become variables into your Terraform script that creates a template file that then gets fed into Nomad. So you're kind of automating that deployment cycle, and you're leaving Terraform as the only, let's say, front door for your developers. Yeah, absolutely a pattern that I've seen.
Fantastic. All right, a couple of questions. I like this one, a personal favorite of mine. It's anonymous. I sort of loathe 8KRS, to be honest, and I'm finding Nomad Consul involved much easier to operate, even with MTLS. But would you say that Nomad is a one-on-one competitor with Kubernetes?
I would, I think a huge open source project like Kubernetes, is always going to have the weight of its community behind it, right? And when you've got enough practitioners using a platform, they come up with enough customizations, enough like heavily requested features that become a real pull request. So that project is always going to be moving and always going to be doing exciting things. But I'm yet to see a team who's moved to Nomad hit any really major roadblocks around what they're doing with that platform, unless it's something very specific. So look, I would say absolutely, it's a platform, that we see companies migrating from Kubernetes with success.
Fantastic. Yep. You've got all the questions. There was one last one that was, I think it was answered about latency. I think we got to that one on our share. Let me just check. Yeah, I think we got that. So the question was about network latency requirement for Nomad servers expect 10 milliseconds or less. Nomad servers can be spread across multiple data centers if they have low latency connections between them to achieve high availability. And folks,
the last thing I'd add there, just the latency between a server and a worker can be much higher. So you can have a single server cluster, and then all of your worker nodes can be really spread around if you want them to be. So there's, it's not as tight for server to client.
Yeah. Well, folks, look, that brings us to the end of our session today. We hope you found it useful. As I mentioned earlier, the session was recorded, and we'll send you the link to the recording in an email soon. If you like what you heard today and want to learn more about Nomad, maybe with your team, reach out to our Nomad team. You can reach us at Tony Fan, and that's tp@hashicorp.com, or please visit the Learn pages on our website, which you can find at learn.hashicorp.com. Thanks again for joining us today. And big thank you once again to Dan. I've done a marvelous job today for presenting. Enjoy the rest of your day, and bye for now.